So today we're going to be finding the size of a matrix, and we're going to be converting between an augmented matrix and systems of linear equations. So have you guys done any math with a matrix before? You did some?
I don't think I paid attention. But
Okay. So a matrix is a rectangular array of numbers that is usually named by a capital letter. Each entry in a matrix is referred to as A sub ij, where I is the row it's on, J is the column it's on. Matrices are often referred to by their dimensions as an n by m, indicating there are m rows and n, that's backwards. If it's an n by m, there are n rows and m columns. That's terrible. Okay, look, change this. Make this an m by n. That's the way we normally talk about it. M by n, where there are m rows and n columns. So, for example, here in this matrix, going top to bottom, these are the rows. So there are 1, 2, 3 rows. Okay, and then across, these are the columns. So there are 3 columns. So we could say that this matrix is a 3 by 3 matrix. Or that's sometimes referred to as a square matrix. Can you guess why it's a square matrix? That's fine. Because the rows and columns match. So anytime the rows and columns match, it's a square matrix. So here, so this is going to be us practicing identifying the dimensions and locating specific entries. So what would be the dimensions of this matrix? It's also a 3 by 3. And then what is the entry in position A sub 3, 1? So this means we're looking at the third row, first column. So in position A sub 3, 1 is a 3. And now what about in position A sub 2, 2? That means we're going second row, second column. There's a 3 there as well. So here we're just looking at the two matrices and identifying their size. So the one on the left, what would its size be? It is a 5 by 3 matrix. There are 5 rows, 3 columns. What about the second matrix? Everybody good with that? Last question. If I had a 3 by 9 matrix drawn, how many different entries would have to be in that matrix? You just find that by multiplying. Okay, so what we're going to be doing next is converting between augmented matrices and systems of equations. So a matrix can serve as a device for representing and solving a system of equations. To express a system in matrix form, we extract the coefficients of the variables and the constants, and these become the entries of the matrix. We use a vertical line to separate the coefficient entries from the constants, essentially replacing the equal signs. When a system is written in this form, we call it an augmented matrix. So what they're saying is normally with an augmented matrix, we can see there are 3 different variables, and then there is the constant that's over here on the right side of the equation. So typically when we draw an augmented matrix, we will draw a line between the 3 variable terms, the 3 coefficients, and the constant, the one that's on the other side of the equal sign. You kind of see how that's replacing the equal sign. Notice that we don't make it a bracket like we do with a regular beginning and end of a matrix. We're just going to use a vertical line to separate them. And then when we're filling out the augmented matrix, we never put variables in it. We just put their coefficients, and we're going to keep them all in the same order. So it looks like we've got A's in the first column, N's in the second column, and X's in the third column, and then the constants in the fourth. So typically, if you're not told, you go alphabetical order, and that's what this is as well. A, then N, then X. So filling this out, what's the coefficient of the, looking at the first equation? The coefficients are 1, -5. Okay, what about the X term? There is no X term, so we have to put a 0 as its coefficient. And then 400 is the constant. 3, 1, 1, 350. 5, -10, 1, 300. Well, I know what I would default to. I would default to X, Y, Z. So there would be my system of equations. Remember what we learned yesterday. If there are 3 variables, we need at least 3 equations to solve it. So that's what's happening here. 3 variables, 3 equations. And just housekeeping, anytime I write a Z, I write a line through it. That way you'll tell the difference between my Z's and 2's if you're looking up at my paper. Z's have lines. So kind of like how when we were solving systems using elimination yesterday, that's where I can multiply an entire equation by a certain number. We can do that with matrices. And that's called a row operation. Now that we can write systems of equations in augmented matrix form, we will examine the various row operations that can be performed on a matrix, such as addition, multiplication by a constant, and interchanging rows. Performing row operations on a matrix is a method we use for solving systems of equations. In order to solve the system of equations, we want to convert the matrix to row echelon form, in which there are ones down the main diagonal from the upper left corner to the lower right corner, and zeros in every position below the main diagonal, as shown. So right here, this is row echelon form. I have ones on the diagonal, and everything beneath the diagonal has to be a 0. Okay? If you get that, you're in row echelon form. We use row operations corresponding to equation operations to obtain a new matrix that is row equivalent in a simpler form. Here are the guidelines to obtaining a row. In any non-zero row, the first non-zero number must be a 1. It's called a leading 1. So basically, the first coefficient that's not a 0 must be a 1. Right? It either has to be a 0 or 1. 2, all 0 rows are placed at the very bottom. So if you have a matrix that becomes all zeros, what is that like in elimination? Remember when we had 0 equals 0? That's what that's talking about. If it's zeroed out, move that one to the bottom. Thirdly, any leading 1 is below and to the right of a previous leading 1. So that's just helping get the ones in a diagonal. And 4, any column containing a leading 1 has zeros in all other positions in the column. Okay? To solve a system of equations, we can perform the following row operations to convert the coefficient matrix to row echelon form and do back substitution to find the solution. So here's what they're saying. First, we can interchange rows. Remember, these are representing 3 equations, right? Each row is an equation. You can switch which equations in which row anytime you want to. You're allowed to switch. That's what 1 says. 2, we can multiply an entire row by a constant. That's like we did yesterday with elimination. I take an entire equation and multiply it by some number. And 3, we can add the product of a row multiplied by a constant to another row. So after we multiplied an equation, then we would combine it with a different equation. Right? That's all that third one's saying. Basically, all the rules of elimination you're still doing here in reduced row echelon form. Okay, find the reduced echelon form of this augmented matrix. So I know if I'm going to get it in echelon form, I need 1s along the diagonal. Right? So I always start with position 1, 1. I want that to become a 1, but it's currently a 4. So you've got options. You could either multiply that entire row by a constant, or we can move an equation into that spot that already has a 1 at the beginning. I think in this case that would be easier. So I'm going to switch rows 1 and row 2. So this becomes 1, 1, 1, 200. 4, 0, -3, 100, and -1, 0, 1, 300. Okay, so I just switched rows 1 and row 2. Everybody's okay with that? Next, I need everything beneath that leading 1 to be a 0. Right? So I need to zero out that entire column. So what I would do is I would take this row 1, I'm going to multiply it by something and combine it with the second column. Right? So what could I multiply the first row by that would eliminate this 4? -4. So I'm going to take -4 times row 1, and I'm going to combine that with row 2. So that's what I'm doing right here. -4 times row 1 plus row 2. So what would that look like? That would be -4, -4, -4. So this is scratch work on the side, okay? It's not a new entry. And then row 2 stays the way it was. And then we are combining them. -4 and 4 is 0. -4 and 0 is -4. -4 and -3 is -7. Right? And 100 and... That's not supposed to be a 200, is it? I knew something was messed up. Nobody called me out. What should that be instead of 200? It should be -800. Everybody with me? -800 and 100 gives -700. So now this is going in the place of row 2, right? So this is going to be my new row 2. I'm just making myself a note. You guys will probably be able to tell really quick. You know how I'm like scatterbrained and all over the page. This is probably not going to be the best way to organize all of my thoughts because, again, I'm all over the place. I'm just going to keep this. I'm going to write it down to remind myself this is going to be my row 2 in just a second. But before I write it in, I want to go ahead and eliminate this one as well, right? Because I need to eliminate everything that's underneath that row. So how could I eliminate a -1? I could just combine them the way they are, right? I don't have to multiply row 1 by any constant. So now I want to take row 1 and combine it with row 3. And so that would give me 200, combined with -1, 0, 1, 300, which gives 0, 1, 2, 500. And so this here is going to become my new row 3. Now, as I'm looking at this, you guys have any thoughts before I write those down? I have a thought, but I don't know if I'm doing too much at one time. Right, so I'm going to have 1, 0, 0, which is what I want. What's going to be my next step then? Is to make this become a 1. But if I put that row 2 in here, it's going to be a -4. But if I switch it with the row 3, this will already be a 1. You follow? Because I can switch rows at any time. So even though I had those in place of row 2 and row 3, before I actually write it, I'm going to switch those. So I want the other one to become row 2 and then row 3. So I'm going to write this on a new page. 111 200. 111 200. This good with everybody? No? I mean, we're not finished. We're not finished. I'll tell you, at this point, are we good? Now, so I've got a 1 here. I've got zeros beneath it. I've got a 1 here. Now I need zeros beneath it. So the next thing I want to do is zero out this -4. So I'm going to combine 2 and 3 to zero out that second column. So this would be, what would I need to multiply row 2 by? 0, 1, yep. So what I'm going to do is I'm going to take row 2, I'm going to multiply it by +4, and then combine that with row 3. So 4 times row 2 plus row 3, that's going to be 0, 4, 8. 4 times 500 is 2,000. And then I've got 0, -4, -7, -700. If I combine, that's 0, 0, 1, 1,300. And so this is going to become my new row 3. So this is going to be 1, 1, 1, 200, 0, 1, 2, 500, 0, 0, 1, 1,300. And so for the way we're doing it right now, we have this in row echelon form, right? It's not reduced row echelon form, but this is row echelon form. And so now then, for now, the way we're going to solve this is, think about what that last equation says. What's this saying? 0x plus 0y plus 1z equals 1,300. So this is literally telling me z is 1,300. And so remember, what are we doing? Solving. We're solving a system of equations like we did yesterday. So yesterday we were looking at two-dimensional lines, and I'm finding where they intersect. Okay? Here, what did I have? I've got three-dimensional lines. And so there's going to be 3 things that can happen. Actually, there's a few more. But kind of the same idea. We could have the 3 lines all intersect at a single point in 3 dimensions. And so because I found the z value, then I would need to go find the y value and the x value to find the ordered triple. Right? It's not an ordered pair, it's an ordered triple in 3 dimensions, where the three lines intersect. So I know a point, or I know a coordinate of that point. Once I know that, I can do what? I can go back in, plug it in, to find the coordinates of the next point. So I don't want to plug into this equation y, because I don't know the x or the y, but I know the z. If I plug into the second equation, I know z. I don't have an x. So then I'll just have one unknown, y. So I plug into here to find the y, then I'll know the y and the z, and then once I know both of those, I can plug into the top one to find the x. Okay, so it's basically like we've simplified our elimination, and we've got the first coordinate. Now we're going back and plugging in. Going back and plugging in. I'm wanting you to see the parallels to how this is really just fancy elimination. So anyways, if I plug 1300 in for z into the second equation, that would give me 1y plus 2 times z, which is 1300, must equal 500. So y plus 2600 equals 500. I subtract 2600 to get negative 2100. Everybody good? Everybody with me? Now I know the y and the z. So I'm going to plug both of those in to the top equation to find x. So that's 1x plus 1y, which is negative 2100, plus 1z, which is 1300, must equal 200. So negative 21 plus 13, that's negative 800. And then add 800, so I get 1,000. And so the point in time where they all meet is at 1,000, negative 2,100, 1,300. It's my ordered triple. So this has 2 answers, okay? This is, if it asks me just for put the matrix in row echelon form, this would be that answer. This is row echelon form. If it asks me to solve the matrix, this is that ordered triple, where they all intersect. So it looks like when I actually read back, it didn't ask me to find that this time. It just asked me to put it in row echelon form. So we're kind of working a step ahead to get to here.
So you said that is it reduced?
It's not reduced row echelon form. It is in row echelon form, but not reduced row echelon form.
Yeah.
It does, but it's a misprint because it doesn't even say row. You see that? It just says, so it's supposed to say row echelon form because I know if I look at the next equation, it only says row echelon, it doesn't say reduced. I'm just assuming it's not supposed to be reduced. To be reduced row echelon form, these are zeros and these are zeros. And I just have ones across the board. But we're not going to get into that right now. That's just, it's going to be 3 more steps, like what I've already done. Yeah, exactly. We don't want to get into that. You guys try the next one. Let's see, so hopefully, let's see, we've got, my first step would be take row 1 and combine it with row 2. Right, because that's going to get rid of the 0 from the very beginning. It's going to give me a 0, I should say. If we combine those, that's 0, 1, 3, 5. So here is a row. And then I would combine rows 1 and row 3. But I need to multiply row 1 by -2. Right, would be my next step. So I've got -2 times row 1 combined with row 3. So it's going to look like -2, +4, -6, -18. Combined with 2, -5, 5, 17. It's going to be 0, -1, -1, -1. So now if I write my matrices back out, I'm going to have row 1 didn't change. Row 2 is now 0, 1, 3, 5. And this is 0, -1, -1, -1. Everybody's okay to hear? So now I got a 1 here, I've got zeros here. Good. Next, 1 here. Huh, nice. Okay, next thing, 0 here. Well, I need to combine rows 2 and 3 to make this become a 0. Well, it's going to 0 out anyways, right? Just by combining it the way it is. So I'm going to go ahead and combine rows 2 and rows 3. So I'm going to do that up here. Row 2 combined with row 3. It's going to be 0, 1, 3, 5, and 0, -1, -1, -1, which gives 0, 0, 2, 4. And that's my new row 3. So now I've got 1, -2, 3, 9, 0, 1, 3, 5, and 0, 0, 2, 4. That's good to hear. 1, zeros, 1, 0, 1. So how can I turn this into a 1? If I multiply the entire row by a constant. So I'm just going to multiply this row by 1/2. Right? If I multiply this bottom row by 1/2, they'll turn this into a 1.
So you can multiply any row.
By a constant at any time.
And why couldn't you just multiply that row by -1 before?
When? Like when it was here?
Yeah.
Well, if I did, this would still have a 1 in its spot.
Yeah.
If you go in that order, I promise it makes it easier. Because, like, when I was telling Kylie before, like, if you don't 0 this out, then when I start combining this row other places, then this 2 is going to get back in the mix. And so even though I 0'd this out, the 2 might show back up here. And I'm kind of defeating my work. So I got to get 1, zeros, 1, 0, 1. Do it in that order. So if I multiply the bottom row by 1/2, so I'm just doing 1/2 row 3, then I can change that to be, I'm just going to erase it this time because I don't really have enough room. That's going to be a 1 and a 2. So now what do I know? I know Z has to be 2. Once I know Z is 2, I can plug that in here. 3 times 2 is 6. Right? And then I move the 6 over. It becomes negative 6. 5 minus 6 is negative 1. Are you okay with me doing that in my head without writing it down? I'm running out of space. I can write it down if I need to. I plugged 2 in for z. So this was 3 times z. 3 times 2 is 6. And then I moved the 6 over. It becomes a negative 6. So 5 minus 6 is negative 1. So 1y equals negative 1. I'm just going to go with it. Okay? Now if I know those two things, I can plug both those into the top equation. So this would be negative 2 times negative 1 is 2. 3 times 2 is 6. So I've got 2 and 6 is 8. I move that 8 over. It becomes negative 8. 9 minus 8 is 1. So 1x equals 1. So the ordered triple is -1, -1, 2. Point where they all intersect.